So hello guys, today's LeetCode problem is a maximum candies allocated to the k children. So what does this problem says that you are given a zero index integer array candies. Okay, we are given the integer array candies where each element in array denotes the pile of candies of size candies of I. Okay, you can divide each pile into any number of subpile. For example, if I have given the candies 10, I can divide it either 1 1 1 1 so on till 10, or I can divide it in 2 comma 2 comma 3 comma anything, whatever I want to divide it I can divide it. You are also given an integer k. You should allocate the piles of candies to the k childrens. This is what we have given over here. We have to we have to divide that piles to the k childrens, so that the condition is that each child gets same number of candies. So our task is to divide the candies array, okay, into equal number so that each children can get the same number of the candies. Each children can be allocated candies only from one pile, and some piles of the candies may be unused. So it is not like that ki I have one child and if I have two piles like 2 comma of 2, I want to allocate the 4, so I can't do like that ki giving this 2 candies to this guy, giving this 2 candies to this guy. This is not possible. A single child should get either only from the one candies, either it can be 2 or 1, it's fine, but only from the one candy he can get it. So that is a given condition over here. So now let's understand this problem. But what is our goal, by the way? Our goal is to that return the maximum number of candies each child can get. Make sense? So if you have solved cocoa eating bananas or any binary search problem, it is the same of that kind, where our task is to divide something. You know, right? Whenever there is a trick actually. Let's understand this with a simple test case over here. What is the test case given as 586? This is the given to us 586, and we have given a 3 childrens, right? So just tell me, looking at the 5 comma 8 comma 6, tell me how many maximum number of candies you can give to the single child. If given children, okay, child equal to 3, given that, and you have the 586, maximum candy to the single person can be given is a maximum of this array. Makes sense? This is something you know, right? This is the maximum of this array, because maximum is 8. So you know that thing, you can at max you can give only the 8 candies to the single child, because one child can get a candy only from the one candy pile that is given to the one child, right? One child you can give it. And tell me one thing, what is the minimum number of candies you can give to the one child? That would be 1, right? 1 only, because I can divide 5 in such way like 1 comma 1 comma 1 comma 1 comma 1. So one candy from the pile I can give to the one children. This is minimum. So you know, right, whenever you have such kind of the problem where you know the fixed range of your problem, where search space basically, so maximum is here 8, minimum you can give is 1. So you have a fixed search space, you know your answer would be lying only within this range. Now that would be the 1 comma 8. Make sense? Now you can see output for this problem is a 5. How it is coming up, let's see. Now let's write this problem over here. So for me the given array is a 5 comma 8 comma 6. Okay, now what is my minimum, or I would call it as a low, would be the 1. What is a high for me? High for me is now for 8. Makes sense, right? And how many children I have? K equal to 3 given in the problem only. They have given me the k equal to 3. What I will do, I will try to search the maximum possible answer within this 1 to 8. Initially, right, we know whenever we have low, high, whenever we have fixed range, the technique or the algorithm that comes into our mind is nothing but the binary search, because binary search will help you to divide your search space by half at every iteration. That is a fixed thing you should know. So what I will do, I will take mid of these two things. So mid is now nothing but mid is equal to low plus high by 2. This is a standard formula we know. Make sense? What is the low plus high by 2? That is nothing but 1 plus 8 by 2. That is 9 by 2. That is a 4. We are just taking, we are not talking, considering the remainder as of now. So mid is 4. Now let's try, we will have some function over here. For example, I will call that function name as a def possible. Okay, I have the function which checks whether it is possible to give 4 candies, whatever the mid I am getting, to the array or not. Okay, so what is my given array? 5, 8, 6, and my task is to assign at most 4 candy to each children, right? This is what I want to check now, whether it is possible to assign 4 candies to the each children or not, so that all children will get the candy. And how many children are there? K, right? K equal to 3, that is given. So let's try to do it basically. So I have 5, 8, 6. I came here. I have to assign 4. I have to assign here the how many candies? 4. So can I assign the 4 candies or not? Yeah. Why I can assign? Because this candy of I has maximum 5 piles. So 4 you can assign. 1 is unused. It's fine. So you assign that to the one child. How many children you can assign using this? So 8 by 4. Simple, right? 8 by 4. That is, you can assign it to the 2 children. I will come here. 6 by 4. That will be the only one. I am not talking about the remainder as of now. So in total, if you want to assign a 4 candy to the each children, how many children you can feed? Basically 1 plus 2 plus 1, that is a 4. But how many children you have to feed? Only 3. So it means it is a good case only, right? If you can feed 2 extra children, it means yeah, it is a possible. So if it is a possible, right now your answer, if I maintain any answer variable over here, for example, if I maintain my answer, I want answer as much as possible, maximum, right? My answer is 4 now. Initially it was 0. I got 4. If it is possible, what is your next step? If I am getting something is possible, I will try to maximize my answer. How it is done? I will update my low equal to mid plus 1. Make sense? Because I want to increase my answer as much as possible until unless my condition is becoming true. What is my mid plus 1? Mid was 4. Now my low is 5 and high is same 8. Now what is my new mid? My mid will be 8 plus 5, 13 by 2. That would be 13 by 2 would be 6. Now I will try to assign a 6 candies, if it is possible or not, to the each children. So I will come here again. Now my array is this. I will just erase this part. Okay. Now let's try to assign the 6 candies. If I want to assign 6 candies to children, can I use this pile? No, you can't use it. Why? Because 5 by 6, simple would be 5 by 6 will give you how many children you can assign the candies, given that you have to assign the 6 candy to the single children. So 5 by 6, that is a 0. So you can feed 0 children using this pile. Make sense? Let's move ahead. Here 8 by 6, which is 1. Make sense? So yeah, I can assign to the 1 children. So I will just write here for a better understanding. So here you can assign 0, you can assign 1. Here 6, so assign 1. So 1 plus 0 plus 1, that would be 2. But how many children you have to feed? 3. So no, it's not possible to assign 6 candy to the single children. So if it is not possible, my case would be to shrink my range to the downside, not upper side. So in this scenario, what I will do, I will update my low will be same. I will update my high equal to mid minus 1, because mid minus 1 will give me the lower range now. So mid was 6, so 5. Make sense? Now what is my new mid now? So if both are same, it will be mid also will be same. 5 plus 5, 10, that would be the 5. Now I will try to assign the 5 candy to the each single children. So I will just remove this part again. Okay, I have to now assign 5 candy. So 5 by 5 would be the 1. 8 by 5 would be the 1. 6 by 5 would be the 1. So 1 plus 1 would give me the 3. How many children you have to feed? 3 only. So yeah, it is possible. So if it is possible, I will update my answer to by new maximum solution. So answer would be now 5. Make sense? So now if you see, I have got something possible, and you know, right, whenever something is possible, I will try to increase my range to the upper side. So my low will become now mid plus 1, that is a 6, and my high is becoming 5 only, as it is. So whenever my low is crossing the high, it means I have to stop my iterations now, because I have done with a range, whatever range I had. So what was our pseudocode for this? Pseudocode for this was that, Okay, I will just write here the pseudocode. Pseudocode was that low should be the 1 always, because I can at max I can assign only 1. High should be the maximum of array, given array. That is one thing. Right. I will run my loop until my low is okay less than equal to high, because I will do something whenever it is less than equal to high. In this condition, okay, in this iteration, what I will do? I will calculate the mid. Make sense? I will calculate the mid. Mid will be nothing but high plus low by 2. Okay, there are other formula as well. Okay, you can use that as well, but it's fine. You just want to find a mid. You have already function. What is the function? If possible, you will define that problem where you will pass the array and the mid, and you will check if it is possible to assign mid candies to the k children. If it is a true, then what you will do? You will increase your range, that is low equal to mid plus 1, and you will update your answer equal to max of whatever the answer you have seen so far, or mid, because mid is possible, assign k children. Or else what you will do? Or else you will do just shrink your window or range size to the lower side, mid answer. That's it. And ultimately you can return your answer variable, because answer variable is containing the answer. And you can assign, initially you can put answer equal to 0, because it is possible that you can assign 0 candies to the children as well. So let's see the code for this. So code for this is simple only, whatever I told you. What I have done here, I am assigning low is 0, 1, high is maximum of the candies, answer is initially as 0. As I said, I will run my loop until low is less than equal to high. I am calculating the mid. I am checking the possible function for using this candies array. If it is possible to assign the mid candies to the k children, if yes, then increase my range size, because I want to find maximum answer. At every step I am putting the maximum value into the answer, or else I am decreasing my range size. And what is each possible function? Nothing. I am just making up the count here over here. I am just going through the each candy. I am just taking same, right? Candy divided by mid. I am counting it. And if it is possible to find count shows how many children it is possible to give mid candies. So if it is greater than equal to k, it means yeah, it is possible. I will return true, else I will return false. So time complexity for this problem would be, so it is a binary search, so it will be log n. And for every iteration, if it is returning true, you are running big of n times. So it will be the n log n. So time complexity for this problem would be the n log of n. Make sense? And space would be the big O of 1 only, because you are not using any extra array over here. So yeah, this is how you can solve this problem. I hope you got it. See you in the next video. Thank you.